Hi everyone. In today's talk, I'll want to give a brief introduction to all the things that people can use for generative AI for creating images and video. So basically an intro to GenAI for vision. This was actually an internal talk that I gave at a presentation at ML6, which is a Belgian AI consultancy firm that implements a lot of generative AI use cases for companies in Belgium, the Netherlands, and Germany. And I decided to make a re-recording of that session, and then I can share it with everyone on my YouTube channel. So in this presentation, I will just go a bit over all the things that were developed until today, because today we have some very impressive models for generating both images and video. But of course, it initially started with some very blurry small images that weren't working that well yet. And so there's a lot of development that went into having the models that we have today. So that's the first part. And then I will also talk a bit about the business models, like how companies can make money with generative AI for vision. And finally, I will conclude with some future trends, some things that I will think will happen in the next coming months and years. But let's start with how we got to these impressive image and video generation models that we have today. Before 2018, there's of course a lot of development. I cannot describe all of the models that were invented to generate images or video, but some like notable works include the Pixel CNN paper by Google DeepMind. There's WaveNet. There's also the VQVAE paper, which is also from Google DeepMind. And initially people were experimenting with what is called unconditional image generation. So it basically means that you just create images that look like they come from some real data set, like for example the ImageNet dataset, or as shown on this slide, the CFAR10 dataset. And people were just trying to have create AI models that can generate images as if they were present in that dataset. Back then they were still very, very blurry. So as you can see also in this tweet by Andrej Karpati, like 5 years ago we were seeing pictures which were very low in terms of resolution, so only 32 by 32 pixels, where you could like potentially recognize a bird or a car in there. But this was like the state of the field back then. So it's important to know where things got started. And so these results here come from this Pixel CNN model, which, if I remember correctly, generates the pixels autoregressively, so one at a time, from left to right. But of course, that's a big difference with what we have today. But so this is just to illustrate that back then people were just mainly experimenting with unconditional image generation by learning the distribution of some domain, of some dataset like ImageNet or CFAR10. But then in 2018 there was an important paper by NVIDIA called StyleGAN. And so StyleGAN is based on the GAN's paper. GAN is short for Generative Adversarial Networks. And this paper, StyleGAN, was able to generate super high resolution images of people. So you could basically not distinguish anymore whether a picture was an actual human or whether it was generated by an AI model, StyleGAN in this case. And so there's even a person who created this website called thispersondoesnotexist.com, and every time you refresh the page it generates an image of a person that does not exist because it has been generated with StyleGAN. And so StyleGAN was really an important paper. As you can see, it's still unconditional image generation. So here again people were taking, in this case, the FFHQ dataset, which is a collection of a lot of faces, and then they were training this StyleGAN model on it. And so yeah, it's a GAN, it's a generative adversarial network. So it basically consists of both a generator neural network and a discriminator neural network, where the generator is trained to generate the images and the discriminator is trained to distinguish between whether the image is an actual real image or whether it was generated by the generator. But so this was, like, I would say, the very first paper that where we couldn't really distinguish anymore whether results were generated by an AI model or not. So this is why I included this in this presentation. And then another important paper was by OpenAI 3 years later in 2021, the CLIP paper. CLIP is short for Contrastive Image Language Pre-training. And the reason why CLIP is so important is because it's able to connect images with corresponding language, with corresponding text in a really good way. And so the CLIP model itself is actually a fairly simple model because it just consists of two parts. There is a text encoder, so a text encoder which is transformer-based neural network, and an image encoder which is also transformer-based. And so the model is basically trained, so these two encoders, the text encoder and the image encoder, are trained to make sure that embeddings of images and corresponding text, so captions which were collected from the internet, images and text which correspond to each other, they should also have embeddings that are very close to each other in the embedding space. And images and text that have nothing to do with each other, which are not linked to each other, their embeddings should be far apart from each other in the embedding space. And so what you basically do in this contrastive pre-training method is you just collect a giant amount of image text pairs from the web, because the internet is full of images with then like a small caption below it, for example on Wikipedia. So you collect a massive amount of these, and then you train both the text encoder and the image encoder jointly, where for every batch of image text pairs that you have, you send the text through the text encoder to obtain embeddings. So embeddings are like vector representations that a computer creates for these texts, and you do the same for the images. So you send your batch of images through the image encoder to obtain the image embeddings, and then you basically try to maximize the dot product between the embeddings of the images and the text that correspond to each other in that batch, and you try to minimize the dot product between embeddings of image text pairs that don't belong to each other in that vector space, in that embedding space. And so if you do that on a massive amount of data, on a massive amount of image text pairs, yeah, you get very powerful image and text encoders, because in that case what you can do is called zero-shot classification or zero-shot prediction. So what you can do, for instance, if you have this image over here, you could simply forward that image through the pre-trained image encoder to obtain the embedding. And then you can do the same for a certain amount of text that you have. Like in this case, we have the text plane, car, dog, and bird. We turn each of those classes into a sentence, like a photo of a, and then we replace object by one of these classes. And then you can basically encode or embed each of those texts to obtain the embeddings for each of the texts. And then you can simply look at the dot product between the text embeddings and your image embedding, and you simply return the highest dot product as the prediction of the model. So this is called zero-shot prediction, because we don't need to train anything additionally. We just take our pre-trained text encoder and our pre-trained image encoder. We compute the dot products, and we can immediately tell what this image may look like. So in this case, for example, the image corresponds best with the caption, a photo of a dog. And so CLIP was super useful, because this will basically allow all these researchers that were training image generation models to also link them with text, and basically will allow us to generate images and then also video later on based on text prompts. And so this was actually already happening quite soon after the release of CLIP. So people were already experimenting with, back then GANs were really popular. So the GANs, generative adversarial networks, were quite popular to generate images. And so people were combining CLIP the model from OpenAI with GANs to try to generate images based on text prompts. So this was like the very first start of the text to image and the text to video later on area. So back then models were called Big Sleep, for instance. There's VQ-GAN Clip. But so all of these models, they were basically leveraging the Clip model to try to condition these image generation models on text. So you use the text encoder of Clip. So basically, actually, we don't need the image encoder anymore of Clip. We only use the text encoder to turn it into an embedding. And then we use that embedding to condition the generative adversarial network to generate images. And so back then, yeah, we were already starting to see some nice results, which like look very bad compared to the results we have nowadays. But back then, for example, if people were sending in the text a pyramid made of ice through one of these models like Big Sleep, then this is what came out. And so back then, people were already really impressed by this, and there were all sorts of creative images coming out of these models. And also quite funny is that people were already finding prompt engineering tricks. So for example, this tweet over here said that if you added Unreal Engine at the end of your text prompt, then you basically get better images as a result. So people were suspecting that Unreal Engine has a collection of very high resolution images on the internet. And so if you added Unreal Engine at the end of your text prompt, you basically get better results out of this. So this can be seen as maybe one of the first prompt engineering tricks back then. But this is like 2021. So yeah, after that, things evolved quite quickly. Because after Clip, and actually I think in the same week, OpenAI not only released Clip, but also DALL-E. And so DALL-E was actually the first very impressive text-to-image model. So yeah, there's this famous text prompt, an armchair in the shape of an avocado. Because yeah, as you can see, the results are quite impressive for that time. Because of course, yeah, they were testing these models on all kinds of weird text prompts just to make sure that those aren't present in the training data. And so, yeah, it was quite nice to see that the model was able to generate weird, abstract things, or just things that are not in the training data. But yeah, people were actually even suspecting that there might be even avocado-shaped chairs on the internet, because the internet is so large. But yeah, results like these were super impressive. And back then, a model like DALL-E was not based on diffusion yet. Diffusion came later. DALL-E combines a transformer, which is also the neural network architecture used in models like Clip and GPT, with a VQ-VAE. So VQ-VAE stands for vector quantized variational autoencoder. But then after that, diffusion started to take over. So diffusion came around 2020 with the original paper by Jonathan Ho and others called Denoising Diffusion Probabilistic Models. And then a bit later, some researchers at OpenAI released the paper Diffusion Models Beat GANs on Image Synthesis. And so from the moment diffusion was released, it quickly became clear that they were going to overtake the GAN models. So people were switching from using generative adversarial networks towards diffusion models. I'm not going to go into detail regarding how diffusion models work, but for that I would recommend some blog posts like the annotated diffusion model, which is one I wrote on Hugging Face. That's a shameless plug. And then after DALL-E, so OpenAI released DALL-E 2 in 2022. And this was diffusion based, where it was using the Clip model for conditioning the model on text. So if you then, for example, specified the text prompt a corgi playing a flame-throwing trumpet, then you would first encode that text using the text encoder of Clip to obtain an embedding to obtain a text vector representation. And then, yeah, you would basically condition a diffusion model on that text embedding. But again, I'm not going to go into details regarding the entire process because DALL-E 2 is quite sophisticated. And then, yeah, from that moment on, results started to look very, very impressive. So after DALL-E 2, OpenAI released DALL-E 3, but many other players started to appear, like Midjourney being a very popular one. It actually became the most popular Discord server because initially people could only use Midjourney through Discord. Google came with their Imagine 3. There is Ideogram, which is another player in the generative AI space for vision. And all of these players are closed source, so it means that you can only use their models through an API or through some kind of web interface. There's no access to the model, to the underlying model. You can just, basically you need to pay for all the images that you generate by sending a text prompt to their website or to their API, and then you get response back. And as you can see, the results look super impressive. Like this is an image here that I took from the DALL-E 3 paper by OpenAI, where if you have a text prompt like an illustration from a graphic novel and so on, it's quite a detailed text prompt, but this is the image that comes out of that. And another result here on the bottom left is from the Imagine 3 paper by Google, where results, as you can see, look quite impressive. And so I'm pretty sure that most of these players are currently using diffusion-based models, also with a new architecture or a new basically training paradigm called rectified flow matching. Basically they also not only use very high quality images to train these models on, because initially people were just training on like very low resolution images like CFAR10. Then this moved on to training from internet images. But nowadays, most of these players actually have exclusive contracts with companies that have a large collection of very high quality, very high resolution images. Like, for example, Getty being one of them. And they also use a lot of synthetic captions. So not only captions that can be found online on the internet, but also using, for example, AI models that can take in an image and generate a caption for it. And this way, one basically collects much higher quality text captions for the corresponding images. And here, I want to briefly take a moment to discuss stable diffusion, because stable diffusion is quite an important both paper and model, because this model is quite unique in the sense that it was open source. So it was fully released. People could access the weights of this model, and people could get started with this model locally. So this was released by Stability AI. So some researchers in Germany trained this model on a GPU cluster from Stability AI, and it came with a paper called Latent Diffusion Models. The reason why they are called latent diffusion models is because they are not trained on the pixel space, so they are not, like, the model doesn't take like the individual pixels of an image directly as an input. Rather, it is trained in a latent space using a vector quantized variational autoencoder, or VQVAE. So basically, a VQVAE consists of an encoder and a decoder, which basically allows you to compress images into a smaller, compact, latent space. And so the stable diffusion model is then trained within that latent space. And then finally, when the stable diffusion model has generated some image, it basically generates these latent embeddings, and then you still need to use the decoder parts of the VQVAE to turn that back into an image. So again, stable diffusion, of course, as the name suggests, is based on diffusion. And for conditioning the model on text prompts, again, the clip model was used. So people were using the text encoder of a pre-trained clip model. So yeah, I also highly recommend to check out the paper. It's super detailed and very insightful regarding how this model, which was state of the art at the time, works. And so this model also gave birth to the diffusers library by Hugging Face. So Hugging Face is a quite known player in the AI world because they are known to be like the home of open and collaborative machine learning. So Hugging Face develops a lot of open source software, which you can find on GitHub, where you can basically get started with state-of-the-art AI models in a few lines of code. And so through the diffusers library, people could just start to generate these images on their own laptops, for example, or in Google Colab. So as you can see, it's just a few lines of code. You can import a stable diffusion pipeline in Python, and then you can, for example, send a text prompt like a photograph of an astronaut riding a horse through the model, and the result looks quite impressive, as can be seen here. And then another project which became very popular on GitHub is called Stable Diffusion Web UI. So this is based on Gradio. Gradio is a tool, a Python library, which allows people to create web interfaces, basically demos for machine learning models in a very easy and accessible way. And so someone on GitHub started creating a web interface, a web UI, for starting to experiment with all of these models like Stable Diffusion. And this became a very popular project on GitHub. So if you Google Stable Diffusion web UI by Automatic 111, this is like a very popular platform which allows you to not only send text prompts through one of these models, but then you could actually chain them together with other steps like image to image, where, for example, first you generate an image from the text prompt, and then you send that image to an image to image pipeline, which then takes in your existing image and then transforms it again based on another diffusion model, and so on. So yeah, this became very popular. Another very popular tool that people are using is called ComfyUI. So ComfyUI, similar to the Stable Diffusion Web UI, is an interface which allows people to experiment and create workflows for creating very impressive images and in the future also video. But ComfyUI works a bit different. It has like a drag and drop interface, as you can see right here, where you can stitch together the various components of these models, like for example the clip text encoder, to then generate an image. Like in this case, it also takes in some start image, and then based on your text prompt, like in this case, photograph of Victorian woman and so on, it will generate that image. So it basically allows people to build all kinds of sophisticated workflows. If you want to get started with ComfyUI, I would recommend to search for tutorials on YouTube. There are plenty of YouTubers creating tutorials for creating workflows with ComfyUI. This is another example of a ComfyUI workflow where, for example, you can send an existing text prompt through 3 different AI models, and you can then quickly see the results on the right. Yeah, and then I want to talk about Flux, because Flux is a super impressive, openly available text-to-image model by Black Forest Labs. So Black Forest Labs was actually created by the people that created Stable Diffusion, because after they created Stable Diffusion at Stability AI, they decided to build their own startup called Black Forest Labs. They already raised like, I think, $40 million to create the most impressive text-to-image and text-to-video models, and then also make them openly available on Hugging Face. So as you can see right here, they have their own organization on the Hugging Face website. And so this year they released the Flux model on Hugging Face. And so Flux comes in 3 versions. There is Flux Schnell, which is the smallest variant, which is openly available on Hugging Face and has an Apache 2 license. So you can find it over here. So an Apache 2 license means that everyone can use this model for free and for commercial purposes. So people can actually make money with this model. Fluxional is the smallest variant and is basically a distilled version because it has been distilled from the bigger models. So the second model that they released is called FluxDev. FluxDev is also available on Hugging Face. So it's openly available. You can download the weights from Hugging Face, but it does not allow for commercial purposes. So it's, as you can see right here, the license specifies that you can use this model for research purposes, but it's not allowed to make money with this model basically, unless of course you use the API from Black Forest Labs, because they also do provide an API from which they make money. And then the third model they did not release on Hugging Face is called Flux Pro, because Flux Pro is only accessible through an API. So this is basically the closed source model, which is of course also the best performing model. So that one is only available through various platforms, including the API of Black Forest Labs themselves. But so yeah, the Flux model is very, very impressive if you look at the results, as I will show in the next slides. But in terms of architecture, it's based on flow matching. So flow matching looks to be similar to diffusion in terms of training, except that the loss function looks a bit different. I'm not an expert regarding that, but I do know that the neural network architecture that is used in models like Flux is also based on transformers. And so yeah, this figure over here, which I collected from Reddit, basically explains in detail how the neural network transformer looks like for Flux, and it's conditioned not only on the CLIP model from OpenAI, but also on the T5XXL model, which you can find on Hugging Face as well, which is a language model by Google. And so yeah, this model is basically conditioned on 2 text encoders. The reason for that is that as you will see, Flux is also really good at rendering text within images, and so initial models like Stable Diffusion struggled quite a bit with rendering faithful text in images. And so there's this paper, I think from Google, where it turned out that using character-aware models greatly improve the text rendering capabilities of models. And so by conditioning the model on these 2 text encoders, Flux is able to generate text within images really well, which you can see right here. So for example, here on the right, someone prompted Flux to generate an image of a person giving a presentation about Flux itself. And so you can even specify in your prompt, like the PowerPoint slide needs to have 3 bullet points. And as you can see, you can even not distinguish anymore whether this image was real or fake. This image was actually generated by this Twitter account, which I follow, and I would highly recommend if you want to follow the latest and greatest news regarding generative AI for vision. Because, for example, you can also do very nice things like generating the text cat, but with the word cat, where the shapes of all the letters combine to form a cat. It works really well, as you can see right here. So yeah, Flux is pretty amazing at rendering text within images. It's not only great at rendering text, it's also great at just generating super realistic images, as you can see right here. These images, I think the text prompt here was something boring Snapchat pictures from 2015, and as you can see, the results look super realistic. Of course, Flux has also been trained on some very high resolution, very high quality images to be able to generate images like these. Okay, so that's a bit the brief history of all of these models. So I would say in terms of openly available models, Stable Diffusion and today Flux are the most important ones to know, besides all of the closed source APIs that we have, like Midjourney, Imagine by Google, DALL-E by OpenAI, Ideogram, and so on. Another very important thing I want to talk about is ControlNet. Because ControlNet, which has been developed by a researcher at Stanford, allows people to basically have better control over the output of these text-to-image models. Because, yeah, of course, if you send a certain text prompt through one of these models, yeah, you get some image out of it, but it's very hard to control, yeah, what will come out of it. Basically, you want to steer the generation in some ways, and so ControlNet allowed to do this. I'm not going to go into the details of how ControlNet works. For that, I would recommend to check out the paper on Archive. But basically, it allowed to do nice things like these. For example, let's say you have an image of your dog. What you would do is you would extract in this case, the Kenny Edge map from that dog image. So Kenny Edge is something that, yeah, you can do with libraries like OpenCV in Python. And then you can, using ControlNet, you can generate images that precisely still maintain the structure of your original dog, but then, yeah, with different dogs based on your text prompt that you give. And so in that way, yeah, it basically allow people to have precise control over the form and the structure of what will be generated. So in this case, yeah, people were actually using stable diffusion combined with this ControlNet ID, yeah, to generate images conditioned on a Kenny Edge map. But ControlNet came with a set of conditioning methods. Kenny Edge maps were one of them, but there were actually multiple ones. Like, for example, line maps was another one where, yeah, you could generate, for example, in this case, different interior designs based on line maps, which is of course super nice and creative, because that way, yeah, just based on text prompts, people were able to generate different looks for an existing room, for example. So yeah, ControlNet is a very, very nice ID. These are some other very cool examples that I saw on Twitter from the same Twitter account, where you could, for example, extract the Kenny Edge map or the depth map, because ControlNet also comes with depth conditioning, where you condition the image to be generated based on a depth map. For generating company logos, where you still maintain the structure of that logo, but yeah, you can like alter it a bit based on your text prompt, which is quite nice. Like in this case, we see the logos of Starbucks and Burger King conditioned basically on the structure of their respective logos, which is quite cool to see. Another amazing application of ControlNet is the illusion diffusion demo, which I think became a super popular demo on Hugging Face. So yeah, demos on Hugging Face are called Hugging Face spaces. So this is a space where people were also leveraging the ControlNet ID for generating images where you also still maintain some kind of structure, like in this case a spiral. And yeah, in that way people were able to generate some very creative images, like in this case a certain street in the town where we still maintain that structure of the spiral, which is, yeah, super creative, because as you can see, for example, the clouds are then generated still maintaining that structure. Even the flowers over here are still maintaining that spiral structure, which is, yeah, a super creative application of ControlNet. Yeah, there are some other examples, like this is a nice video which basically shows how illusion diffusion works. So let's say you start from certain text prompt, like a beautiful town in Greece, with this conditioning. So this is actually the image that people were using to condition stable diffusion combined with this ControlNet ID on, and then yeah, this is what comes out of it. So as you can see, the image still maintains that structure of this cross, but it's generating an image that still looks super realistic. So yeah, this is the idea of illusion diffusion. And yeah, something that actually got released this week, which is very related to ControlNet, is Flux tools. So Black Forest Labs released some ControlNet models for Flux. So this basically allows you to condition Flux on, for example, some depth map, and then you can generate images like these, which is quite creative to see. So in this case, for example, let's say you have this image, you extract a depth map or you extract a canny edge map from it, and then it basically allows you to generate all kinds of different images based on the conditioning. So that's quite cool, because now this means that it will also work with the state-of-the-art text-to-image model that we have today, which is Flux. And so yeah, they actually did not only release models for this control net ID, where you condition the model on some on something like a depth map or a canny edge, but also for doing things like Inpainting. So Inpainting is also a very popular application of text-to-image models, where you basically condition the model on some kind of image, and you basically prompt the model to fill in a certain masked area. Like in this case, let's say we start from this image, but we want the model to replace this area over here. So you can basically draw this mask over here, and then you can, using a text prompt, decide what you want the model to generate. Like in this case, this blue jacket. Or another example here, this is pretty cool because, as you know, Flux is quite good at rendering text. With this Flux Inpainting model, you can actually now just replace text within images and it will still maintain that same font, which is super cool to see. So in terms of Inpainting, yeah, this Flux Inpainting model was actually just released on the hub. You can actually just get started with this now locally. But this is all very easy to use through the diffusers library. So diffusers, which, as I already said before, is the open source library developed by Hugging Face, which provides easy access to all of these state-of-the-art text to image and as well, so later on, describe text to video models, and actually also text to audio models and so on. So this is all available in the diffusers library. And so they also have a guide on doing Inpainting with diffusers. So in this case, for example, let's say you start with this image and you are using this mask, so you want the model to only replace the white area. Then if you would specify this prompt, yeah, it would generate this image. But yeah, this example over here is not using Flux. I think this is using an older model called Kandinsky. But again, like, you will be able to do this with this new Flux Inpainting model through the diffusers library as well, which is super nice to see, because as you can see, it's not a lot of lines of code. With just a few lines of Python, you can do this yourself. So that's Inpainting, which is another very popular application of these models. Another popular application is Outpainting. So in Outpainting, we don't want the model to fill in a certain masked area, but in this case, we just want the model to expand a certain image, basically fill in some missing parts. Like, let's say we have this image of Elon Musk. Yeah, you can just prompt these models to fill in the surrounding borders of the image. Like in this case, you prompt the model to generate black suit, and as you can see, yeah, the suit that is being generated looks super realistic. This demo over here is again hosted as a Hugging Face space, so you can actually already use it here for free on Hugging Face. And again, it's open source, so if you click here on the Files tab and then app.py, you can see all the code that goes behind this Inpainting, which seems to be using stable diffusion in this case from the diffusers library. And again, diffusers does provide a lot of guides regarding this. Like, there's a very nice blog post series by Alvaro, who works at Hugging Face, and he wrote some guides on doing outpainting in a very advanced way using diffusers. So for instance, in this case, let's say you have this image over here, you can then do all kinds of outpainting using diffusers. All right, and then so I talked about ControlNet, which is a super clever way of making sure that we obtain better control over the outputs of these models. I talked about Inpainting and Outpainting, which are two very also popular applications of these models. I also really need to mention DreamBooth in this presentation. Why? Because DreamBooth is a super popular way of personalizing these text-to-image models. Because so these models like Flux or Stable Diffusion are all trained text image pairs from the web. And they might know about celebrities like Elon Musk or Taylor Swift, but they might not know about you, or they might not know about your dog, for instance. And let's say you want to be able to generate your dog in all kinds of different situations. Well, with this DreamBooth method, this became possible. So with DreamBooth, you could just collect a few images, let's say 4 images, as shown in this case, and then using the DreamBooth method, you could basically adapt a model like Stable Diffusion or Flux to generate your dog in whatever situation you want. Like, for example, your dog in front of the Acropolis, or your dog swimming, your dog sleeping, or getting a haircut, for example. And so, the DreamBooth model, which was developed at Google, I think was initially closed source, but the open source community quickly provided an implementation of this, and so now it's also easily accessible through the diffusers library, for instance. So again, I'm not going to go into the detail of how DreamBooth exactly works. For that, I would recommend to check out the paper. But basically, what you do is like you expand the vocabulary of the text encoder that is used in these text-to-image models, like CLIP, for instance. So you add basically a specific special embedding that you learn for your new concept. For example, your dog. But it could also actually be a certain style on which you want to fine-tune one of these pre-trained text-to-image models. And then you end up with a personalized model, which is able to generate your concept in whatever situation you want. And so, DreamBooth basically fine-tunes an existing text-to-image model. And so a problem here is that these text-to-image models are often quite large in terms of size. Like, for example, this Flux model that I just described is having 12 billion trainable parameters. And if you look at the size of these models on Hugging Face, you will see that it's quite large in terms of number of gigabytes. So you can actually, diffusion models consist of all kinds of modules, but you can also find here the file that contains all of the modules in one, and as you can see, it's about 23 gigabytes. And if you want to fine-tune models like these, you will need a multiple of that in terms of GPU memory, which quickly makes it infeasible for people to fine-tune these models. But so luckily, there is this method by Microsoft called LoRA. LoRA is short for low rank adaptation, and it's a very clever technique which allows people to basically fine-tune these models on consumer hardware. For example, on a single RTX 4090 NVIDIA GPU, or on platforms like Google Colab. And the idea of LoRA is that we are going to freeze, or basically not touch, the existing pre-trained model. So we're not going to update the weights of a model like Stable Diffusion or Flux, but rather we're only going to add a couple of linear projection layers on top of such a pre-trained model. We're only going to train those layers. So those layers are also oftentimes called LoRA adapters. So in this case, they're shown here in orange. So basically what happens is we're going to take the weights of such a pre-trained model like Stable Diffusion or Flux, but we're not going to touch them. We're going to keep them frozen, shown here in blue, and we're only going to train these smaller linear layers, these LoRA adapters on top of it. And this basically will allow us to train these models even on consumer hardware where memory requirements are a bit lower. And so people are also using this a lot for fine-tuning large language models like GPT, ChatGPT-like models, but it also works really well for text-to-image models or text-to-video models. And so, there's this nice space as well on Hugging Face called LoRA the Explorer, which is just a collection of all kinds of popular LoRAs that people train on top of models like Stable Diffusion and Flux. I think the LoRA, the Explorer space, collects all the LoRAs that people train on top of Stable Diffusion. And then, as you can see, there's also a space which then seems to be broken right now, but which goes over all of the LoRAs that people train on top of Flux rather than Stable Diffusion. And as you can see, there are some very, very creative works that come out of it. One example here is a yarn art style LoRA, So yarn, yeah, is some kind of art, I assume, and so people were training a LoRA on top of Stable Diffusion for generating images in that yarn style, and then you can, for example, generate Albert Einstein in that style, which is, yeah, super creative work of art, if you ask me. So yeah, DreamBooth allows people, yeah, to basically personalize such a text-to-image model on a certain concept, on a certain style, and then people combine this with LoRA, which is basically the idea of just training a couple of linear layers on top of these models. And so, yeah, there are a huge amount of LoRAs available on Hugging Face. So there's also this nice model tree feature now on the hub, where you can actually browse all of the LoRAs that people train on top of Flux Dev, for example, in this case. And so, yeah, here I've included some of my favorite ones. Like there's a Mona Lisa LoRA. So someone trained or fine-tuned Flux to only generate images of the Mona Lisa. And then you can basically, for example, generate the Mona Lisa in a nightclub, which is quite fun, or the Mona Lisa at a sunset, for example. Yeah, as you can see, the number of people training adapters, so adapters actually refers to LoRa adapters, has, I think, nowadays already crossed more than 5,000. Another very fun LoRa is the Ostrich model. Sorry, the model trained by Ostrich, which is a popular Twitter account. So in this case, someone trained a LoRa on top of Stable Diffusion for generating IKEA instructions. So that's super funny, of course, because if you just collect a few IKEA instructions and then train a LoRa on top of that, you can basically generate an IKEA instruction for any concept, like where is Waldo, or sleep, for example, which is quite funny as well, or a hamburger, and so on. So the LoRa itself can also be found on Hugging Face. And as you can see, it's an adapter, so it's a LoRa trained on top of the Stable Diffusion XL model by Stability AI. So yeah, this is just to show all kinds of the creative stuff that people are doing with training a LoRa on top of Stable Diffusion or Flux. This is another very popular LoRa, and this one is not really a concept, it's really trained on just a style, namely photorealism. So there is a realism LoRa on the Hugging Face hub, where it basically allows people to generate super realistic images. Yeah, where it's basically becoming impossible again to distinguish between whether the image has been generated by an AI model or not. So this is one of the examples of images that comes out of it. So this is using this realism LoRa on top of Flux, which was quite popular on X. All right, and then, yeah, another super nice concept, if you ask me, is the idea of combining, or also called stacking, multiple LoRAs on top of each other. So this is actually quite next level, if you ask me, but basically, let's say you have trained a LoRa on the Mona Lisa, and you have also trained a LoRa on the Meta Orion glasses, which is like a new product released by Meta. You can simply just combine these two LoRAs, and then you can generate the Mona Lisa wearing those glasses. So this is shown over here, again from that same source on Twitter, which I'm following a lot. And yeah, this basically allows you to just do a summation of two concepts, like in this case the Mona Lisa with those Meta Orion glasses. And again, it's super easy to do with the diffusers library. As you can see here on the left, it's just a few lines of code to load the LoRa weights of two different LoRAs that you train, and then you can generate an image where those two concepts are combined. So yeah, this is a pretty powerful and very creative concept, which basically allows you to just combine different concepts to generate a certain image. So if you want to try this yourself, well, there's actually different ways to do this. So either if you don't want to do any coding, in that case, I would recommend to check out platforms like Replicate, which basically provides a no-code solution to train a LoRa on top of Flux There's also Fel, which is another popular platform for training a Flux LoRA. So as you can see, you just need to upload a few images. You can then start a training run. It will cost you a few dollars. If you want to dive deep into the code, I would recommend to check out the AI toolkit by Oostries, which provides scripts which are based on the diffusers library. And then you can actually fine-tune these models yourself on a GPU. I think you can do that on an RTX, for example, or an A100 GPU. As you can see, you need 24 gigabytes of VRAM. And this is actually what I also did myself. So I trained a Flux LoRA on some images of myself. Well, it's actually still using this idea of DreamBooth, of personalizing a text-to-image model on some new concept, in this case, me. And you train a LoRA on top of that. And so then I was able to just generate an image of myself at Times Square, holding a cardboard that says, I can finally DreamBooth myself. So yeah, this is quite amazing that just with a few images, I think I only collected 5 images of myself, you're able to do things like this. And this is the code that you need for inference. So it's just, as you can see, we are loading the pre-trained Flux model from Hugging Face. We load our LoRA that we trained on top of it. And then you can just generate whatever you want. So I could generate myself in whatever situation I want. Of course, there are many text-to-image models coming out. You might wonder how to know which ones are the current best ones. Well, I already mentioned Flux being the current state of the art. I'm pretty sure that in a few months or or at least a year from now, it will definitely be another one for open source. But for that, I would recommend to check out this Hugging Face space, which is created by Artificial Analysis. So they maintain this leaderboard where you basically always see 2 different images, and people need to vote which one of the 2 images they prefer. Based on that, one can calculate so-called ELO rates, ELO rankings, which is also something that is used in chess to rank chess players, because basically you can calculate the win rate of these models based on that. So as you can see, Flux is quite popular. They're quite on top. Flux 1.1 Pro and Flux 1 Pro are not openly available. You can only use them through an API. Recraft, same for that. It's only available through an API. Same for Midjourney. But yeah, as you can see, Flux Dev, which is in 6th place over here, is also quite high in the rankings and is openly available on Hugging Face. All right, so yeah, that was about a bit like a brief history of how we got to the models we have today. Now let's talk about business models. How can companies make money with these models? Well, I just collected a few examples here of companies and people who try to make money with these models. I'll just go over them one by one in the next few slides. I also recommend, if you're interested, to check out the podcast on Lex Friedman with Peter Levels. Peter Levels created a website called photoai.com where he generates quite a lot of revenue with these models. But yeah, let's just go over all of these examples. So one example is Playground. So Playground basically tries to become a generative AI platform for graphics design. So whenever you want to generate a wallpaper, a poster, a t-shirt, a social post, and so on, you can use their platform, and they actually have their own in-house text-to-image models, and they also actually released some models on Hugging Face as well. So Playground can also be found on Hugging Face, as you can see. It's also a very popular text-to-image model, and so they basically try to compete with Canva. So if you know Canva, they are a quite popular graphics design tool for creating social media posts, for example. But they try to integrate much more AI features into that. So this is definitely one of the ways that people are making money with these models. Another example is from Peter Levels that I mentioned. So Peter Levels created photoai.com. Yeah, he makes it, of course, quite drastic by saying fire your photographer if you go to their website, photoai.com. He basically makes the case that it will become much cheaper to generate images of whatever you want, for example, of your products of a certain person. So you don't need to pay for photographers anymore. He says you don't need to pay for the models that need to be hired for generating images. And with his platform, you can generate images like these in just a few seconds. So this is definitely also one way. Again, as you can see right here, this is also using the concept of DreamBooth. I'm pretty sure there's some Hugging Face software behind the scenes over here with diffusers. And this basically allows you to generate images or product pictures in whatever situation. And so Peter Levels is what is called an indie hacker. So an indie hacker basically means that you try to just bootstrap an ID yourself on your own, try to make money with certain ID as basically a SaaS, so software as a service. And you also do it in a quite open way. So Peter Levels shares quite a lot of details regarding how he gets to now. He seems to be earning like $100,000 per month with his website, photoai.com, which is also, of course, due to the fact that he was on the Lex Friedman podcast. So it's just to show that there's definitely some money to be made with these websites. Another example that I saw on X is Flare.ai. So Flare.ai is a San Francisco-based startup, which also leverages IDs like ControlNet, DreamBooth, LoRA, on top of the Flux model to basically generate marketing. For example, generate some content for your products in any scene. So this is also, I would say, one of the ways that people are trying to make money with these models. I think I included another example over here. Actually at ML6, which is the consultancy company where I work at, we're also actually experimenting with these models, with building ComfyUI workflows, for example, and then stacking those LoRAs on top of each other. So in this case, for example, let's say you train a LoRA on top of this person, and then you also train a LoRA on top of this clothing piece. By just stacking the LoRAs on top of each other, you can then actually generate that person wearing those clothing pieces, which is like super cool. Which probably is also will allow us to sell some business cases for this, because of course many companies might be interested in generating more marketing, or for example creating a virtual try-on on their website using these latest techniques. All right, so that's for business models. And then finally, let's go over some future trends. What are things that we might see in the next few months or years? I would say in terms of future trends, there are two big ones. So one is image to video. So where we're gonna see these images brought to life. So we're not gonna just see still images, but they're actually gonna be moving. And another trend I would say is turning them into 3D. So making sure we can see images from all sides. So in terms of image to video, there are some popular platforms. One is Runway, which is a New York-based startup. And with their Gen 3 model, which is their latest model, you can basically turn an image into a video. So let's say you have generated this image. This is then, for example, what can come out of it using their Runway platform. Of course, as you can see, results still don't seem perfect, but it's already quite amazing that you can then also animate your images like this. Another popular platform is called Kling AI. It's a startup based in China. And they have all kinds of cool features. For example, let's say you have this image and you want the car to move in that direction, you want the dog to move in that direction, and you want the person to move in that direction. with their platform, yeah, you can just generate the video from that image. I think this might be using the segment anything model to generate those segmentation maps. Although it seems that here they're just drawing the mask on top of the image. But yeah, this also basically allows you to have better control over how the video is generated for a certain image. This is another funny example that I saw on the internet for the founding team of OpenAI. So let's say you want them to all move away from Sam Altman, the CEO of OpenAI. It's quite funny to see what people are doing with these models. All right. Another example here that I found is, so let's say you use the Flare.ai platform for training LoRAs on top of some clothing piece. So this is actually all trained on the same clothing piece, but as you can see, you train different AI models for wearing that piece. Then you can actually use Kling AI to then animate those images and basically already have a video where those people are walking and wearing those clothing pieces, which basically allows people to automate marketing as well. So yeah, image to video, text to video, I would say are definitely trending, and there's a lot of research going on. There's a lot of new models being released on Hugging Face. Like lately we saw a huge increase of the number of openly available text to video and image to video models. One popular example is Mochi 1, but there are actually many more. So on Hugging Face, actually, if you go to the models tab, where you can actually now find more than 1 million models. Of course, on Hugging Face, most of the most popular models are large language models. But as you can see over here, you can filter on all of these different domains within artificial intelligence, all of these different tasks. And so you can actually also filter here on text to video. As you can see, there are already more than 150 models available. And so, yeah, Mochi 1 is like a popular one, which was recently released on Hugging Face because it's like the state of the art right now for generating video from text. It's quite a large model, but yeah, it even is available under a commercially permissive license. So you can just download the weights on Hugging Face right now. So yeah, there's lots happening here. I would say right now, the videos that we see being generated are like up to like a minute long. But I think a future trend will probably be that we will have like fully generated movies. Because right now, yeah, we have very short clips of just a few seconds up to like a few minutes at most. But I would definitely see, I could definitely see this moving towards having fully generated AI movies. And then, so the other trend is image to videos, where we basically, turn an image into 3D. So in this case, this is another space that I found on Hugging Face. It basically allows you to see all the sides of a certain image. So you might wonder what is the use of that? Where can we use models like these for? Well, this is very useful for creating assets in gaming, for example, but also for the animation industry or for the design industry. This is gonna come in very handy. For example, let's say you have some products on your website, you have images for them, but you want people to look around and see all sides of the product that you're selling. With this image to 3D models, it will become possible. So another example here that I think will be very useful also for companies like Booking.com, Airbnb, real estate. Let's say you have collected these images of a certain scene. With this new model called Master, you can basically turn that into an automated 3D scene, which directly allows you to explore the scene in 3D. Just based on the images, the AI model was able to do that. So I think this will also be an area which is going to become very popular and very powerful. I think for real estate companies, for example, this is also going to be very useful. Let's say on Airbnb you have posted a few pictures, but people want to have a look around of how the apartment, for example, looks like. With these AI generated 3D, maps, this will become possible. So for the real estate market, this will also become very, very useful. All right, so yeah, this was my brief introduction to generative AI for vision. I hope you enjoyed it, and I will also definitely include a link to my slides at the bottom of my video. See you, bye-bye.